Hello everyone. Today we're going to work on adding and subtracting radicals, multiplying radicals, and rationalizing a denominator. Now since this could be a little bit long, I'm showing all 8 different examples I'm going to be going over, color-coded. The black ones are going to be adding and subtracting, the green ones will be multiplying, and the red ones will be dividing. So if there's one particular thing you're looking for, fast forward and find what you need. So here we go. First off, with addition and subtraction work the same way. It's essentially a task of combining like terms. What you're looking for in each of these pieces is the radical and the radicand, right? In this case, the square root of 6 and the square root of 6. If they match, then you can add these two things, essentially like that distributive property from way back in the day, and you simply combine like terms and get a 12 roots of 6. And that's it. So you're literally just adding the 10 and the 2 together. I have another one here that is the same concept, right? So this is a cubic root of 3x, but they're the same. So it's just 4 minus 5, so -1 or negative cubic root of 3x. That's really all there is to it. I'll circle the answers here so you can see them. Now, a couple times you'll find yourself, I'm going to look down here, you'll find yourself in a situation where the radicand, that thing that's on the inside of the index of the square root, doesn't match. In this case, we got a 3 and a 12. Well, don't give up on this problem just yet. Try to break this down and see if you can get yourself a perfect square, right? So the square root of 4 and the square root of 3. So what I would find, and I'm going to try to color code my writing, is I already had the 8, and I just created, because of this guy, I just created a 2 and the leftover square root of 3. I already had, here we go with black again, I had plus 5 roots of 3 to begin. And look what I have here. Though I'm going to combine this together, I'm going to get 5 roots of 3 plus 16 roots of 3. So there we go. I can combine those together. 5 and 16 make 21, 21 roots of 3, and we're done. So if they're not the same, you don't give up on it yet. However, there are times, and you're going to see this last one, there are times when they're simply not the same and you can't do anything about it. The 10 would break down to 5 and 2, but that doesn't help me because the 11 isn't going to break down in any similar way. It's prime, so it's not going to break down at all. So in this case, you're done. You can't do anything, so done. I don't know, that's it. Right? You can't do anything. All right, now let's go to multiply and divide. Now, most of the time when we're multiplying and dividing these things, you may see something like 2 binomials being multiplied together. And the truth is, if your teacher ever taught you like the FOIL technique way back in Algebra 1, that's really all you're doing here. 4 times 2 is 8. 4 times negative square root of 2 is -4 square roots of 2. The square root of 3 times 2 is 2 square roots of 3. And the square root of 3 times negative square root of 2 is negative square root of, well, 2 times 3 is 6. Now you can see this is a little bit of a mess. I just came away from adding and subtracting. These are all square roots, but none of these radicands are the same. I know that the 6 could break down. I don't want to give up on it. I just said that. But there's not enough 3s or 2s to simplify in any way, so that doesn't really help me. So as much as this looks like kind of a mess, this is actually the answer. This is it. It's basically 4 terms that don't combine, so that's all you have. Now on the other end of the spectrum, you will sometimes have conjugates, and these often have lots of things that combine together, but we're still just going to use the firsts and the outers and the inners and the last, that FOIL technique. So 5 and 5 make 25. 5 and -2 roots of 6 is -10 roots of 6. This guy is going to give me positive 10 roots of 6. That's what's awesome about conjugates. These two are going to be opposites, and they're going to cancel each other out. And we're going to find ourselves with the last piece. 2 roots of 6 and -2 roots of 6 is -4, and then 6 times 6 is 36. And some of you will probably do that part in your head, but for the purposes of the video, we'll write it down. So here we go. We got a 25. This part in the middle is essentially just 0. I mean, I guess you could say 0 roots of 6, but you know what? We're not even going to bother because it goes away. That's the cool part about it. And we end up with -4 times, in this case, 6. So 25 minus 24, and we're going to get a 1, and that's it. So when you're dealing with conjugates, you should expect to get something that does not have a radical in the end, which is the nice part. And if you've watched this far, here comes the division part. Now, division, This is actually not really a division problem. It is division because we see a fraction bar, but my objective isn't dividing, it's rationalizing the denominator. So in math, we want to avoid things in the bottom that we don't like. For example, like your math teachers don't like decimals in the top of a fraction or in the bottom of a fraction. We don't like fractions inside of a fraction. We don't like imaginary numbers, like complex numbers in the denominator. We don't care about the numerator so much, but not in the denominator. We want to keep that denominator nice and pure, and we don't want radical symbols in the denominator either. So in this particular one, I've seen a lot of my students that will try and multiply by like the square root of 3. You know, square root of 3 over square root of 3, which is just 1, which they're allowed to do, but here's what happens. They think it's going to work, but when they multiply 4 times root of 3, they get 4 roots of 3. I'm showing this not because it's the correct way to do it, but because it's a common misconception. And on this guy, they're going to do, well, they're going to get square root of 3 times the square root of 3 is going to be the square root of 9. So the square root of 9 is going to be a 3. So, yay, we love that. That's awesome, except, look at this, square root of 3. So you find yourself just transferring the radical from basically the second term over to the first term. And you never, it's kind of this like dangerous cycle. You don't get out of it. It doesn't work. It's just not a good technique. So, and it's not a good technique because it doesn't work. So what we're going to do instead is use, I'm going to scroll up here. We're going to use this concept right here. Notice how we had radicals here, and we multiplied by its conjugate. The conjugate meaning it's exactly the same, right? 5, 2, and 6. 5, 2, and 6, exactly the same thing, but this one's a plus and this one's a minus. So we're going to multiply by this conjugate, and what we're going to get is something, whatever we get, we're going to get something that doesn't have a radical, and that's what we want. So we'll get rid of all those symbols. We'll come down here, and here comes the conjugate. It's 1 minus the root of 3, and 1 minus the root of 3, because that makes that the same on top and bottom. And here we go. 4 times 1, so think of this as a binomial, so I'll put it in parentheses. 4 times 1 is 4, and 4 times negative root of 3 is 4 roots of 3. And on the bottom, I'm going to use essentially FOIL, right? So 1 times 1, 1 times the negative root of 3, and now we're going to do the root of 3 times 1, so positive root of 3. As you get better at this, you probably will find you don't even write that piece because these are, just like the previous example, they're going to cancel out. And positive root of 3 times negative root of 3 is going to be negative roots of 9. I'm going to write it this time just so we kind of finish the example. So I have 4 minus 4 roots of 3 over 1 minus 3. The 3 comes from this part. And let's simplify this. 1 minus 3 is just negative 2. And I see 4s, 4s, and 2s. I see a whole bunch of stuff I can simplify. So let's simplify. Negative 2 plus 2 roots of 3 would be the answer. All right, so when I say answer, let me rephrase. It's just a simpler version of the original. It's exactly the same thing, but one is really kind of unpleasant because it has a radical in the denominator, and one is simplified because there is no radical in the denominator. If that's all you need, then you should push stop right now. I'm going to do one more example just in case. This is the same concept. It's just a slightly more challenging problem. And what you should see is, I'm going to use the conjugate again on the bottom and the top. I'll throw everything in parentheses just to make sure that I don't make any mistakes on my multiplication. And I'm just going to FOIL the top, but FOIL isn't really the correct term, but I'm going to multiply the top and the bottom together. So 3 times 2 is 6. 3 times 2 roots of 5 is 6 roots of 5. The root of 5 times 2 is 2 roots of 5. And the root of 5 times 2 roots of 5 is going to be, I'm running out of space here. Let's move this over. Actually, let's do this. Let's steal a little bit of space here from the screen. And let's try again. So the root of 5 times 2 roots of 5 is going to be 2 roots of 25. And we'll make that prettier in just a minute. On the bottom, we're going to do 2 times 2 is 4. 2 times 2 roots of 5 is 4 roots of 5. Negative 2 roots of 5 times 2. So here comes the conjugate piece. So this is minus 4 roots of 5. And just as expected, those things are going to cancel out. And to finish this off, we're going to do negative 2 roots of 5 and positive 2 roots of 5. So negative 4 roots of 25. Let's make this all neat. So on the top, I'm looking at a 6. I'm looking at these two are combining together. They have the same radical, same index, same radicand and same index. So this is going to be 8 roots of 5. And 2 times 5 is going to be 10. So we're going to ultimately combine that 6 and 10 together. On the bottom, we're looking at 4. That stuff in the middle cancels out, and I have 4 times 5. That's where we get the 4 roots of 25 from. So let's finish this off. I've got 16 plus 8 roots of 5. I've got 4 minus 20, so negative 16. And this is the second time in a row we're going to be able to simplify. I don't know that we're always going to be able to, but it seems to be happening for us here. So 16 divided by negative 16, and 8 divided by 16 is 1/2 roots of 5. So a couple different ways you can write that. -1 minus root of 5 over 2. Either one of those is pretty nice. All right, I'll circle them both because they both mean the same thing. I'd probably, if I were choosing, I'd probably pick that one. So that's it. That's adding, subtracting, multiplying, and, well, not really dividing, but rationalizing that denominator with radicals.